Hello! In this video, we will look at the inverter control mode. There are several ways to control the inverter. In this video, we will introduce the control mode built into LS Electric Inverter. The three representative control mode parameters are VF control, sensorless vector control, and censored vector. VF is the most basic control method, and programming for this control method is simple. The sensorless vector, or the censored vector, has the higher control capability. However, it requires complex setup and installation compared to VF control. Next, we will look at each control method. The first is V by F control. It is the simplest control method to operate an electric motor. The most basic data of the motor is used, and tuning and encoder are not required. This makes it possible to control the motor with simple setup and wiring. In V by F operation, the output voltage and frequency of the inverter are proportional. When the maximum number of revolutions is the maximum load of the motor, the slip of the motor makes up the difference in the number of revolutions. Next is sensorless vector control. Sensorless vector control performs vector control without using an encoder. In order to use sensorless vector control, you must enter the motor nameplate information and perform tuning for an accurate operation. Sensorless vector control can produce a strong torque comparable to censored vector control, but it has lower control performance than censored vector because it does not use sensors such as encoders. Finally, censored vector control. For censored vector control, the encoder mounted on the motor is used, or a separate encoder is installed, and the encoder option card is mounted on the inverter. The installed encoder and option card transmit the rotational speed of the motor to the inverter for calculation. In order for the control to perform accurate calculation, it is necessary to set the motor nameplate information into the inverter and tune the motor. The censored vector control is operated by receiving the feedback of the motor. Because of this, it can operate with a stronger torque compared to V by F control. Even when the load increases, the speed of the motor is judged by the inverter to match the commanded rotational speed. Next, we will look at the applications for each control method. V by F control can be applied to most loads that do not require precision. Since only basic information of the motor can be entered and operated, it can be easily applied to fans, pumps, and conveyors that require speed control. Censored vector control with an encoder is applied to loads that require accurate and high torque. It can be applied to winders, elevators, agitators, impellers, etc. Censored vector control requires the installation and tuning of the encoder, and if the tuning is not correct, it may cause problems in operating the motor. Sensorless vector control can be applied to the applications where the censored vector control is used, but the control precision will be considerably lower compared to the censored vector control. Let's program the inverter control parameters. Move to the DRV group and check control mode number 9. iS7 has total of 5 control modes. In this video, we will look at the 3 settings of V by F, sensorless 2, and vector. The first is VF control. The control mode defaults to VF, so no additional programming is required. Go to DRV14 and set the motor capacity. The DRV14 motor capacity does not automatically change other motor information parameters. You must check the motor nameplate information and enter the motor information in the BAS group. Enter the information of the motor nameplate from BAS 11 to 13. The second is sensorless control. In DRV9, change the control mode to sensorless 2. Go to DRV14 and set the motor capacity. The DRV14 motor capacity does not automatically change other motor information parameters. You must check the motor nameplate information and enter the motor information in the BAS group. Go to the BAS group and enter the information on the motor nameplate from BAS 11 to 16. Sensorless control requires accurate input of motor information. After programming, go to BAS 20, Auto Tuning, and then input 1, All. Auto Tuning can be selected between stationary type and rotation type. And here, we will do the first rotation type tuning. Number 2, All Stand Still, means stationary tuning. Rotational tuning is used when the motor and load can be separated, and the stationary tuning is used when the motor and load cannot be separated. When tuning starts, the Tune indicator appears on the keypad, indicating that tuning is being performed, and you can see the LED blink. Since the selection is made by rotational tuning, the motor performs tuning by accelerating and decelerating. When tuning is completed, BAS 20 is changed to none, and it goes back to a stopped state, and you can check that the motor parameters of BAS 21, 22, 23, and 24 have been changed. Finally, censored vector control. For censored vector control, you must use the encoder option. With the power off, install the option card in slot number 3. After mounting, make a selection suitable for the encoder specifications. There are 3 types of encoder specifications: line drive 12 volt, open collector, and line drive 5 volt. In this video, we will set it to line drive 12 volt. After turning on the power, move to the CNF group and check the mounting status of the encoder. You can see the encoder is installed in CNF32. Encoder setting can be programmed in APO group. The setting of the APO group can vary depending on the encoder used. Set encoder option mode to feedback in APO1. This means getting feedback from the encoder. The parameters to be programmed can be entered with the information of the encoder. In this video, the encoder type is line drive. The encoder pulse direction is A plus B, and the number of encoder pulses is set to 1024. After setting the encoder, let's check the direction of the encoder. Set DRV9 control mode to V by F and DRV1 to 10 Hz. Go to APO number 8 and check the value that changes according to the motor rotation direction. When the inverter operates, plus 10 Hz means forward direction, minus 10 Hz means reverse direction. If the direction and the value of APO number 8 are opposite to the direction of motor rotation, check the encoder wiring. Now, change the control mode to vector in DRV9 for operation. Vector cannot be programmed if the encoder is not set up properly. Go to DRV14 and set the motor capacity. The DRV14 motor capacity does not automatically change other motor information parameters. You must check the motor nameplate information and enter the motor information in the BAS group. Go to the BAS group and enter the information on the motor nameplate from BAS 11 to 16. As with sensorless vector control, sensored vector control must have motor information set accurately. After setting all the motor parameters, select BAS 20 Auto Tuning and number 1 All. Auto Tuning can be selected between a stationary type and a rotation type, and here we will do a rotation type. Number 2 All Stand Still means stationary tuning. When tuning starts, the Tune indicator appears on the keypad indicating that tuning is in progress. And you can see that the LEDs of forward and reverse flash at the same time. When tuning is completed, BAS 20 is changed to none and is changed to a stopped state. Also, you can see that the values of BAS 21, 22, 23, and 24 have been changed. Thank you.